functions, just so you know, is a unit that comes up in every single lesson, or sorry, every single unit except perms and commas and binomials. So when people are done the transformation unit, they're like, oh, thank you, God, we're done this unit. Thank you, Lord. And then it comes in the next unit, and then the next unit, and in the next unit, and in the next unit. So first step is denial, that it's not going to be in every unit. Get past that. Okay, acceptance, just get right to there. It is going to be in every single unit except for the one we just did. Okay, so as long as you accept that, once you get into the third and the fourth unit, you're like, wow, why did I find this hard? This is super easy, right? But you denialed for 3 units, so it took you till you got to the fourth to accept it, and then you do well in it. So we're just going to go right past denial. We're going to know this baby's coming up every single unit, and we're going to be stellar at it. Okay? Totally bypassing that. It's going to be great. It's going to be like rock stars. Okay? Last year, you guys looked at quadratics, which is x squared graphs. You looked at absolutes and reciprocals. That's it. This year, we're looking at linear, quadratic, cubic, quartic, quintic, up to degree 5. We're looking at exponential, log graphs. We're looking at transforming any type of function I throw at you. We're doing trig graphs. We're doing graphs where we add, subtract, multiply, divide 2 graphs together. We're composing graphs. So we're transforming all of those graphs. Oh, and radical graphs and rational graphs. So getting on board with transformations is where I need you. Okay? Jump on board of my little transformation train, and we're going to head yonder and do well in it. Okay? Transformation train. Just get on. Get on it. It'll be great. I will bring chips on the transformation train. Okay? Maybe some chocolate for all the people who like that. And you gluten-free people, I will bring things that are gluten-free. Like, only thing coming to my head right now is salad, and I'm pretty sure that's not always gluten-free. I will look for the symbol. Okay? I will bring some vegan options, some vegetarian options. I will have everything. I'll bring water. Maybe some peace tea, because people seem to really like that recently. So we're going to bring all that onto the transformation train. All aboard. Okay? Ready? Cool. Transformation is an operation that moves or maps the figure from an original position to a new position. So we're moving right, we're moving left, we're moving up, we're moving down. We are reflecting in the x-axis, we're going to be reflecting in the y-axis, and we're going to be stretching wider or narrow our graphs. Okay? It's going to be a blast. Get excited. Okay? Those are all the things we're doing in the next 3 days. Today, we're just going to talk about translations. And you've talked about translations in quadratics. You talked about moving right or left or up or down. You guys totally did it. For example, if I gave you y equals x minus 3 squared plus 6. Do you remember what your vertex was? Going back into grade 11? Dig deep. What was it? Yes, it was 3, 6. It was the max or the min. In this case, it was concave up because it was positive. And you would have took the opposite of this and same as this. Why? Because you had the formula either x minus p squared or x minus h squared plus q or k. It didn't really matter. But there was this little minus sign in here. Do you agree? So last year you were taught, okay, cool. You were taught x, minus sign. H actually lines up perfectly with the positive 3, doesn't it? So that's why your vertex was at positive 3. Because we have x, we have a minus, it lines up with the positive 3. So our vertex was at positive 3. And then we had plus sign, and our k lined up with the 6. So our k was 6. Do we agree? So what happened if last year they gave us this? They gave us x plus 3 plus 6. Well, we surely memorized that it was at negative 3 and 6 because it was always the opposite. But why was it always the opposite? Because the form they gave you was x minus h or p squared plus k or q. It didn't really matter. The catch here is I need x, I need ma. A minus sign there. What could I do? Because I need to have a minus sign. How do you get a plus 3 if I have a minus sign in there? It would actually be minus a what? Yeah, minus a negative 3. Do you see that? So now I can line them up. X minus, and what would my h be? Negative 3, and my k is still 6. That's why it's the opposite, because you have that minus sign in there. Transformations will always be the same. You have a minus sign in there. So look here. It has it in the form y minus k, f, x minus h, or y equals f, x minus h plus k. So it's always, your h is going to always be the opposite, and your k will always be the same. Your h moves right or left. Because remember, this is an x value. This is an x value, right? So that's right or left. We agree? And your k always moves what? Up or down. Huge difference between 30-1 and 20-1 is this little funky f that sits in here. The reason why they have the f is I'm transforming an f of x graph. What they could do, this is just a side note, they could give me a graph like this. And they could label it f of x. They don't have to give me an equation of it. They just give me the graph of f of x, correct? Now, when you have that little f in here, it's just saying this is what I'm doing to f. This is transformed form. Whenever you have y equals f of x on this side, this is just transformed form. It's telling you what transformations are happening. So there are 3 ways I can give you transformations. Just give you the words. Say I'm moving this right, moving this left, and you have to deal with it, right? We're going to learn about mapping. That's another way we can move it. There's also when the function, when the equation has an f in it, that's just a fancy way of telling you the transformations without physically writing them in words. It's like if you struggle on a math question and you're like, oh, I don't know how to do it this way, I don't understand this way, and I explain it to you another way. There's another way to do it, another explanation. That's all this is. I can either give you the words and say, hey, I'm moving it horizontally translating it 4 to the right and vertically translating it 3 down. I can say that. Or I can give it to you in this transformation equation, which is another fancy way of giving you how to move it. It's just another way without writing out in sentences. That's all it is when it has the f in it. It's the transformations in an equation. It's just giving it to you in equation form. So, what? If this is x minus h, I'm actually moving it h to the right. Why is that? Because my equation is x minus and then my h. What's my h in this case? It's a positive h, correct? Because the equation is x minus, this is a positive h. So I'm actually moving it h to the right when it's actually x minus h. And when it's x plus h, I'm actually moving it h to the left. Why? Because I need x minus a negative h, correct? So you're actually moving it h left when it's positive, and h right when it's negative because there's that minus sign in there, x minus h. But your k, it's always a plus k at the back, correct? So if it's a plus k at the back, I'm moving it k up. If it's a minus k at the back, I'm moving it k down because it would be plus a negative k. So your k always moves the correct direction. If it's a positive k, it moves up. If it's a negative k, it moves down. Nothing fancy, nothing different, always the same, correct? But your x, which has your h connected to it because it's x minus h, if it's x minus h, it's actually moving h to the right because my h is positive. If it's x plus h, that's the same as x minus a minus h, so it's actually moving left. So your h is always moved the opposite direction of what you think, and your k is always moved the same. Okay? Now mapping. We're not going to deal with replacement notation right now because it confuses the crap out of people. We're just going to deal with mapping. Mapping is how I physically move the x and the y point. Mapping is I have an xy point and I'm moving it blah. Okay? So how you always show mapping is you go, I have an xy. This is what it is originally. And then I'm doing this to it. Your mapping literally just moves what you move. Just cut my hair. It's holding my ponytail. I was doing it every single time. I'm going to stand stable like this and not move very quickly. Okay, so my mapping, stand way over here. My mapping seems really weird on this side. I really complicate to the right, just so you know. But I'm going to be a rebel, stand on the left. So when we do mapping, it's literally how we move. Okay? So if I had this function, y equals, I'm going to use numbers, fx plus 3 minus 6. Let's pretend that's the function I have. If I have x plus 3, what way am I moving? Right or left? Left, because this would be an x minus a minus 3, correct? So I'm moving left 3. We agree? Okay, here's my xy coordinate. Look at me. I'm an xy coordinate. Yep, here I am. Xy coordinate. And I'm moving 3 to the left. Here I am. What did you do to me? You moved me 3 to the left. How do you move 3 to the left with an actual operation? You subtract 3. We agree? Cool. So my xy, my little point, is now going to become x minus 3 because I need to move it 3 to the left, right? How do I move a point that's here? 3 to the left. I subtract 3 from it. Poof, here I am. Okay? What's my transformation if I have a minus 6 at the back? Which way am I going? 6 up or 6 down? Moving 6 down. Here I am. Oh, I should have done something smaller than 6 because I'm going to blow a kneecap. Ready? 1, 2, 3, 4, 5, 6. Oh my gosh. I should be shorter. Okay, here I am. What did I do to me? What did you do to me? You subtracted 6. We agreed to get this coordinate to move down. So our mapping is going to be y minus 6. So mapping is just that you, I did. No, that's point. That's might be why that line's down. So mapping is just doing what you say you're going to do, correct? Because you're literally physically moving that point, that direction. So this is what I'll see on every single person's test when you write it, because it's true. Words, like horizontal translation, 2 to the left, vertical translation, 3 up, correct? And mapping being moving the coordinate, are the same thing, just done in a different way. So I always put them in a heart. And you're like, that's insane. Except on the unit test, every single one you have is written. That will have to be moved. Words and mapping are in the same heart because they mean the same thing. If I'm moving left 6, I'm going to subtract 6 from x. If I'm moving up 7, I'm going to add 7 to y. Right? Words and mapping, same thing. Different way of describing it. Okay? So, if I look at this function, remember we're not talking about replacement for right now. If I look at this function, y minus 2, I have an f in it. So this is my transformed form. What does that mean? It's just the words in an equation form. So what we're going to learn is going from transform form to words to mapping, mapping to words to transform form, words from mapping to transform. We're going to move to all the different forms. Okay? Key thing with transformed form is get it in y equals. So I'm going to add that 2 over. So I'm going to get y equals f x minus 3 plus 2. So I'm just adding the 2 over. We agree? So what type of horizontal translation do I have? I'm going to say horizontal translation. Now some people are like, do I have to write all those words? Yup. What if I don't? You don't get marks. That's how it is. So I have a horizontal translation. 3 units. Where am I going? Right or left? Right, because this is x minus a positive 3. So 3 units. Right. What's the other one? I'm moving up or down, that's vertical, correct? Up or down is vertical. Horizontal is right or left. So I have a vertical translation. Two units, where? Up, because it's a plus 2. This is words. So if I ask you to state the transformations, those are the words, correct? Words and mapping are the same thing, just described in a different way. So if I go to do the mapping, I have to go x, y becomes, that's what the arrow means. I have my little xy. All my little xy's are now becoming what? How am I moving them? So I'm here, I'm an xy. Here I am, I'm a coordinate. I need to move 3 units right. What am I doing? Adding 3 to the what? To the x. The x coordinate's the one that's moving, right? Y moves this way, x moves this way. So I'm going to go x plus 3, and then my vertical translation 2 up. What am I doing to my y? Y plus 2. Then it shows it here. If the point 4, 6 is on the original graph, on the one without transformations, y equals f of x, that's the graph without transformations, it would become 7, 8 on the new one. Well, let's prove it. How do we prove it? Whenever we're moving a coordinate, we use mapping, because mapping moves coordinates. So let's try it out. So we're going to go 4, 6. And now we're going to plug 4, 6 in. So we're going to go 4 plus 3, comma 6 plus 2. And what happens? 4, 6 becomes 7, 8. So the moment you move one coordinate, you use mapping. So mapping is helpful when you're moving coordinates. So if you're moving a graph, you're moving a whole bunch of coordinates, correct? So you still use mapping. When we use coordinates, move coordinates, mapping. Move coordinates, mapping. Move one coordinate, mapping. Move a whole bunch of coordinates, mapping. Okay? And we're going to flip over. Now, what if you just write this spot, but you don't write xy becomes x plus 3y plus 2? Is that mapping? No. Mapping is xy, arrow, becomes what's new one. So if they ask for mapping on the diploma, or I ask for mapping on your unit test, and you just say x plus 3, y plus 2, that's not mapping. That's just a random thing sitting on your page. Mapping is xy, arrow, becomes new coordinate. Okay? You have to do the whole thing if you're going to get marks for mapping. So the next one says, describe how the graphs of the following functions relate to y equals f of x. So I want the transformations and mapping. I want words and mapping. Words and mapping for all 4 of these. You're flipping over. I want words and mapping. So I want the mapping, and I want horizontal translation, blank units, bluff. Vertical translation, blank units, bluff. So for these 4, I want transformations and mapping. Transformations and mapping. Okay, so for A, it's x minus 3, which means we're moving 3 to the what? Which way? Right, so it's a horizontal translation. Three units right. That's it. So my mapping, x, y, I want to move the x3 to the right, so I'm going to have to add 3 to it to move it 3 to the right, and I'm going to do nothing to my y. For B, it's at the back, it's not with my x, so it's a vertical translation. Four units. Which way? Up. If I go to do my mapping, it has to be the same. X, y becomes, nothing happened to my x, it's still there. And I want to move this y4 up. So how do I move y4 up? I add 4 to it. This one, once again, is a y. It's sitting at the back. So it is a vertical translation. Eight units where? Down, because it's negative. And my mapping is x, y becomes x stays the same, and my y minus 8. D has 2 things happening, right? Horizontal and vertical. So I have a horizontal translation. 7, which way? 7 units left, because this would be x minus a negative 7, correct? So it's 7 units left. And a vertical translation 4 units up. Now note to self, if it's in this bracket with the x, it affects your x variable. If it's not in there, it affects your y variable. Okay? So this 7 left, I'm going to have x, y. How do I move 7 left? Well, I have to subtract 7. How do I move 4 up? I have to add 4 to my y. So this one says, what happens to the graph of the function y equals f of x? The following changes are made to the equation. I replace the x with x plus 2. What does replacement mean? It means I go into this equation where the x is, I take it, I throw it across the room, and I replace it with x plus 2. So I take the x, toss it, take the x plus 2, put it in its place. That's all replacement is, right? Take the x, throw it out, replace it with x plus 2. So what is this? It's a horizontal translation. Two units what? Left. Because it is x minus negative 2. Remember, it has to have that minus sign in there. So it's 2 left. Always the opposite. Now this next one is tricked. Remember, this is our equation. Our equation is y equals f of x. I'm replacing the y with y minus 8. Yes? So I'm taking this y off the equation with my hand. I'm grabbing it. I'm throwing it away. I'm taking the y minus 8 and I'm putting it in its spot. Do we agree that's what replacement is? So I'm getting y minus 8 equals f of x. So is that in a good form? No, I always want it in y equals form. So I'm going to add 8 to both sides. And now I know it's a vertical translation. Eight units what? Up. This one says the point 2, negative 3 lies on the original graph, y equals f of x. If it's y equals f of x, it has no transformations. It's the original, correct? State the coordinates of the image of this point under these transformations. So these transformations are happening to a point. If I'm moving a coordinate, what should I use? Starts with an M. Mapping, every single time. Move a coordinate, mapping. Move a graph, there's a whole bunch of coordinates, mapping. Should immediately be in your, soul. See a point, move it, mapping. See a graph, move it, mapping. It's the easiest way. So, this is my equation. I want it in y equals before I do anything. So I'm vertically translating it 8 units what? Down. So what is my mapping going to be? X, y becomes, my x stays the same, and what happens to my y if I want to move 8 down? Just subtract 8. The hardest part is getting the mapping. Now you just plug in the coordinate, right? If you get your mapping right, you have the question right, unless you do some silly math. So my coordinate is 2, negative 3. It's now going to become 2, comma, negative 3 minus 8. So it becomes 2 and negative 11. In B, both the x and the y are changing, correct? Still moving a coordinate, still doing mapping. Mapping and words are the same thing. So I need to figure out the words, then mapping is easy. If my words are right, mapping is easy. So I have x minus 7. Which way am I moving it? 7 to the what? Right. How do I move an x 7 to the right? To add 7, right? So I'm going to get x plus 7. My vertical translation is 5 units where? Up or down? Up, because it's a plus 5. How do I move a y up 5? Well, I add 5 to it. And then I plug in my point. My new coordinate is 9, 2. So they can go all the different ways. I can give you the equation and ask for the transformations of the mapping, right? But I could also give you the equation and give you the transformations and ask for the new equation, the transformed form, correct? So here it is. Write the equation of the image, so the transformed form of y equals f of x after these three things happen. Let's try it out. I'll give you a couple minutes. So here it says horizontal translation 5 units left. Well, what does that look like in an equation? Well, I need y equals f of x minus 5 units left is a minus 5. So it actually is x plus 5. Could you go right to plus 5 if you know it's the opposite? Yes. But that's why it is plus 5, because it's minus negative 5. Okay? This one is 3 up. So y equals f of x plus 3. This one is a horizontal translation, m units right. So I'm going to get y equals f. X, if I want it to the right, what am I going to have to go? Subtract a positive m, correct? And then p units down, minus p. Okay, then we're going to flip to the next page. We're only going to do one of these, so we're going to do B, just so you know. It says, in each case, the graph of y equals f of x is shown. Sketch the graph of the transformations for each. So what's the first thing I'm going to have to do for this one? Get into y equals. Now I'm moving not only one coordinate, I'm moving 1, 2, 3, 4, 5 coordinates. So what am I going to use when I move a coordinate? Mapping, every single time. Now some people might say, well, it's just 3 to the left, 2 down. I can just move them 3 to the left, 2 down. True, true statement. However, on your final, it can have moving left, right, reflecting, stretching, right? So you're going to have to use mapping. So you might as well get used to doing mapping. Okay? So my mapping for this one is going to be xy becomes what? X. I need to move 3 to the what? Left. So I'm going to minus 3. These words of mapping are the same. And then I need to move 2 down. So I'm going to go y minus 2. So we'll do a couple coordinates to show it, and then yes, you can go left and down, left and down. Okay, but I want to prove a point that the mapping works. I hit it again. Awesome. All right. So I need to put in one point coordinate. I'm going to put this one in. 1, 2, 3, 4, 5, 6, negative 7 and 2. So I go negative 7 and 2, and I go negative 7 minus 3, negative 2 minus 2, and my new coordinate is at negative 10 and negative 4. Let's pretend it actually extends. No, it's not going up. It's going down. We moved it over. Let's get in y equals. Yeah. And then we do the other one, negative 5 and 2 becomes negative 5 minus 3, negative 2 minus 2.
No, I mean like in the you said negative 2, negative 2. But it's positive 2. Like
Oh, you mean this part?
Yeah.
Yeah, I'm stunner. True statement. 0? I thought you meant the transformation, not the fact that I'm an idiot with the wrong number for the coordinate. Should have been a giveaway when I went down 4, there was like 6 instead of 2. Should have been a giveaway. Plus 2. So this one's still at 0. Now, find a coordinate, find another coordinate, connect them. Find the next coordinate, connect it. Find the next coordinate, connect it. Because what people will do is they'll find all the coordinates and then they connect them wrong. They like connect different weird ones together. So do it in an order. Like I did this point and this point, connect. Now I can do this one. And because it's only translations, you can just count. So I need to move 3 left and 2 down. So I'm going to go 1, 2, 3 left, 1, 2 down. So it's here. Then I connect. Can you see if people put random dots all over and then they connect them wrong? I see that on the unit test all the time. Do the next point. 3 left. 1, 2, 3, 2 down. So it's here. Connect them. Pretend that's a straight line. Then 3 left. 1, 2, 3, 2 down. And there's your new graph. So when it's just left and down, you don't need to use mapping technically, right? But like I said to you, on a test, they'll often have more. They'll have like a stretch with a translation or a reflection with a translation. Moving to 7. So when you state transformations, it's what has changed. So everything we've done so far is I've given you an f of x and then a transformed equation, correct? Do any of these have f's in them? No, so I'm going from one equation to another and I have to state what's changed. Okay? So here I have x to the 4 and then I take x to the 4 and I add a, awesome, and I add a 3 to it. So what's happened? I'm taking x to the 4 and I'm doing what to it? Vertically translating it 3 up. We agree? So my mapping would be xy becomes xy plus 3. Words and mapping are the same. Words and mapping are the same in a heart. Words and mapping are the same. B, what is the only thing that changed in B? B was a linear equation. That was 6x minus 3. Now it's 6x minus 1 minus 3. Moved it right 1. This is the only thing that changed. My x was this. My x is now this. If it's x minus 1, it's a horizontal translation. One unit right. And my mapping would be xy. How do I move it 1 to the right? Well, I take my x and I add 1 to it. We try C and D. You've got a minute. You have 30 more sessions. Okay, so for this one, it was absolute value of x. We looked at these graphs last year. I'm now moving it 6 to the right and 2 up. So it's a horizontal translation. 6 units right. And a vertical translation. 2 units up. Still one more example. And so then xy becomes x plus 6, y plus 2. Now this one, it's with the x. This is just a square, it's a rational with a square root. Don't let the functions mess with you. You've never seen one like this, doesn't matter. If it's with the x, it affects the x. If it's at the back, it affects the y. So this is a horizontal translation. One unit left, so it's the opposite in the vertical translation. 3 units up. And we have x, y. If I want to move it 1 to the left, I go x minus 1. 3 units up, I want to go y plus 3. And we're flipping over. We'll go through one more thing. What if I give you the transformations and a different equation that's not the F equation, right? I don't want transformed form. I want you to transform an equation. Don't let it throw you off. If it's a horizontal translation, it goes in brackets with the X. If it's vertical, it just sits at the back, right? Nothing crazy. So this one is a horizontal translation, 3 units right. So this is my X. My X is in a bracket like that. It has to join that. So I'm going to go Y equals X, 3 units to the right. I'm going to go X minus 3. Because it goes x minus and then a positive 3 squared. Done. This is an exponential function. You haven't learned about those. You're going to. You haven't. You don't need to know what this is. It's a vertical translation 2 units up. So does it join the x? No, it sits at the back. We get y equals 10 to the x, 2 up, plus 2. If it was a horizontal translation 3 to the right, I would have x minus 3 in the exponent up here. That's it. It would join the x or it sits at the back. That's all it is. People who overthink these are the ones who get it wrong. This is a square root function. We're going to also be doing these. We're doing exponentials. We did quadratics. We're going to do them again. These are all in our curriculum. After a horizontal translation, 4 units to the left. So it's going to join my x, which happens to be under a square root sign. 4 units to the left, it's going to be x plus 4. Vertical translation 3 down, minus 3 behind the radical. That's it. Nothing crazy. You overthink these and you're like, where do I put it? Just put it with the x or at the back. Okay? Don't overthink it. So we're going to flip to the very back because that's where the homework is and I'm kicking off some of the questions. We're going to finish 2 of these examples, 9 and 10 tomorrow. And then we're going to move on to reflections. But at the bottom of this, for tomorrow, I want you to kick off these. 6 and 7, and 11. And this one you can kick out C. About 11 questions. I try and stick around 10 for night. Usually if people work in scheduled help, they can finish at least over half of their homework if you want to work in scheduled help. Okay? These aren't the hardest ones, right?